Okay, in today's video, we're going to play one of my favorite physics games, and that is, will it accelerate? And this is the situation we have. We have an object on this is the object, on an inclined plane. There's no friction between the object and the inclined plane. And we want to know, is the object going to accelerate? Now, in two previous videos, I showed you how to, using Newton's second law, how to calculate the acceleration of an object on an inclined plane, with and without friction. You can link to those two videos right here. But in today's video, we're going to take a little bit more of a conceptual look at why things either do or do not accelerate. Okay, so let's get back to our problem. We have an inclined plane, object, no friction. You should know from previous real life experiences that when you have an object on an inclined plane without friction, that the object is going to accelerate down the inclined plane. It's not going to move up the inclined plane, and if there's no friction, it's not going to just stay there. When you have it there, you release it, you hold it there, you release it, it accelerates down the inclined plane. Well, why does it accelerate down the inclined plane? It accelerates down the inclined plane because there is an unbalanced force acting down the inclined plane. Where does that unbalanced force come from? Well, let's draw in the forces acting on the object. And we have the gravitational force, mg, and we have the normal force. Well, it doesn't really look like at this point we have an unbalanced force acting down the inclined plane. Where does that unbalanced force come from? It comes from the x component of the weight of the object. Part of the weight is acting in the y direction. Part of the gravitational force is acting in the x direction, and it is this force. You can see there's only one force acting along the inclined plane. It is this unbalanced force, the x component of the gravitational force, that causes the object to accelerate down the inclined plane. There's one force, the unbalanced force, mgx, and therefore, yes, the object will accelerate down the inclined plane. Okay, now let's look at the same problem, but let's add friction into the problem. So once again, we have our inclined plane, our object, but in this case, there's friction between the object and the inclined plane. And once again, we want to know if the object is going to accelerate. Now, if it's going to accelerate, once again, even though there's friction, you should know that it's going to accelerate down the inclined plane. If it's going to accelerate down the inclined plane, once again, there has to be an unbalanced force acting down the inclined plane. Well, where could that unbalanced force come from? Well, let's draw in all the forces. And once again, we have the gravitational force, the weight of the object, the normal force, but because we have friction, we drew in the friction force. We drew in the friction force up the inclined plane. Its direction is up the inclined plane because we know if the object is going to accelerate, it's going to accelerate down the inclined plane, and therefore friction, which opposes motion, would be acting in the opposite direction. In order for it to accelerate down the inclined plane, there has to be an unbalanced force acting down the inclined plane. There has to be some force greater than the friction force. Well, where does that come from? Well, once again, it comes from the x component of the gravitational force. If we break the x component, we get a part of it acts in the y direction, part of it acts in the x direction, and this is the force that once again would cause the object to accelerate down the inclined plane. In the x direction, we only have two forces. We have the x component of the weight, and we have the friction force. In order for the object to accelerate, the x component has to be bigger, has to be greater than the friction force. If that is the case, then the object will accelerate down the inclined plane. If the friction force is greater, the maximum friction force is greater, then the object will not move. Okay? Now let's look at a couple examples because there's a special point I want to make. The first example, the mass of the object is 2. The inclined plane is inclined at 30 degrees. The coefficient of static friction. This will give us our maximum friction force if we use the static friction, and that's what we want. The coefficient of static friction is 0.45, and we're going to use G10. We're going to round it to 10 to make our numbers just a little easier to work with. Let's calculate and see if the x component in this case is greater than the friction force, the maximum friction force. Okay, if we want to calculate the x component, it's mg sine theta. M is 2, g is 10, Sine of theta is 1/2. So 2 times 10 is 20 times 1/2, and that means that the x component of the gravitational force, the force acting down the inclined plane, is 10 newtons. Let's calculate the friction force. The friction force by definition is mu times the normal force. We're going to use the static coefficient times the normal force. The normal force is equal to the y component. The y component is mg cosine theta. So in order to calculate the maximum friction possible, the maximum friction force, it's the coefficient of static friction, which is 0.45, times the mass, times g, times the cosine of the angle, and therefore you would do that and you would get 7.8 newtons. The maximum friction force possible, 7.8 newtons, and therefore the object will accelerate down the inclined plane because the x component is greater than the friction force. Okay? Let's try one more example. You can see in this case, we've increased the mass, we've increased the coefficient of static friction, the angle is the same, and we're still using g as 10. Let's calculate the x component. 6 times 10 times 0.5, the sine of 30 degrees is 0.5, is 30 newtons. All right, now let's calculate the friction force. 0.7, 6, 10, cosine of 30, and you get the maximum friction force possible is 36 newtons. The x component down the inclined plane is 30 newtons. The maximum friction force possible is 36 newtons. We have not exceeded the maximum, and therefore the object will not accelerate. It's going to just stay there. Okay, I just want to point out we use the coefficient of static friction, which is greater than the coefficient of kinetic friction. In order to get the object moving, the force would have to be greater than 36 newtons. In this case, if the force down the plane is 30 newtons, then the friction force is going to be equal and opposite. But in order to get the object moving, we would have to have a force greater than 36 newtons. When we use the coefficient of static friction, we're calculating the maximum friction force possible. The friction force we have to break in order to get the object moving. And you can see in this case it's only 30 newtons. So if you use this equation and mg is less, then the object will not accelerate. Okay, so there you go. That's how to figure out if an object will accelerate or will not accelerate on an inclined plane with and without friction. I hope you found that video helpful. I hope you found that interesting. If you did, please subscribe to my channel. Get all my great physics videos. Also, give me a thumbs up, and then you can do all three things: subscribe, thumbs up, and leave me a nice comment in the comment section. Thank you very much for watching. We will see you in the next video.